Right, let's do two examples of how to use the trig identities to prove. So for the first one, on the left, we're going to start with the left-hand side. We have secant theta minus cosine theta, and I'm trying to get to the right-hand side. So remember in proofs, you're not allowed to move things from left-hand side to the right-hand side. You can only start from the left-hand side and get to the right-hand side, or start from the right-hand side and get to the left-hand side. So in this case, we're going to start with the left-hand side, and I know the left-hand side secant is same as 1 over cosine theta minus cosine theta. Now, if you look at the right-hand side, you see that you will end up with one thing, and it's not two fractions. So intuition tells me that I have to combine the two fractions as one. So this is the same as this, same common denominator. That gives me 1 over cosine squared theta or over cosine theta, and I know that 1 over 1 minus cosine theta is sine squared theta. So I know that this can be written as sine squared theta over cosine theta. Now, I need to get tangent. I know that tangent is sine over cosine, so I can split the sine squared into sine theta over cosine squared times by sine theta, which then gives me tangent theta sine theta, which is the right-hand side. Okay. Second example over here, we got lots of sines, cosines, and tans and tangent. Again, I'm going to start with left-hand side. And if you observe on the right-hand side, you only have sine and cosine left, which means that I will have to rewrite tangent and cotangent in terms of sine and cosine. So this is the same as this, plus sine theta over 1 minus cosine theta over sine theta. Okay, so all I did here was rewrite tangent as sine over cosine and rewrite cotangent as cosine over sine. All right. So once I've done that, then I'm going to look at it, the thing and say, well, what can I simplify in the first fraction? This is the same thing as if you look at denominator and combining the denominator to a single fraction with then you're going to get cosine theta over cosine theta. Take away sine theta over cosine theta. And you can do the same thing with the second fraction, which is everything in terms of sine theta. Okay, cosine theta over sine theta. That means this is the same as cosine theta over, on the bottom, it becomes cosine theta minus sine theta, or over cosine theta, plus the sine theta over big massive vinculum. This is sine theta minus cosine theta, or over sine theta. Okay, now we don't like fractions in fractions. So at this point in time, you probably want to rewrite the fraction, the first fraction, as the numerator multiplied by the reciprocal of its denominator. Okay, plus the same thing with the second fraction, the numerator times by the reciprocal of the denominator. Okay, once you get to here, observe that the denominator are almost identical except that they are of opposite signs. So I'm going to factorize out a -1, which means that we're going to end up with cosine theta squared, or over cosine theta minus sine theta, okay, plus the second one will be sine theta squared. But hey, if I factorize out the negative on the denominator to make them the same so I can combine the two fractions, I'm going to end up with this. Okay, which means that this simplifies down to one single fraction, cosine squared theta minus sine squared theta, or over cosine theta minus sine theta. All right. So once you get to here, please do not just cancel them out. You have to show me the factorization of the difference of two squares on the numerator. So the top becomes cosine theta minus sine theta and cosine theta plus sine theta. On the bottom is cosine theta minus sine theta, which means that one of them is going to cancel out, leaving you with just cosine theta plus sine theta, which is the right-hand side. Okay. There we go, right hand side.